We are the creators of Roadside Buddy.
Sorry. Hi, I'm Alex. I'm part of the software team.
I'm Marvin. I'm part of the software team.
I'm Kalani. I'm the team leader and part of the hardware team.
I'm Nick Rutino, and I'm also part of the hardware team.
So, have you ever been driving one day, probably late at night, and then you find that you're falling asleep at the wheel, or you're just getting a little bit too tired, a little bit too comfortable in your car? So, we wanted to create a device that would help prevent drivers falling asleep at the wheel, and also make sure that those drowsy drivers would not risk anyone else on the road. So, one major thing that we had to take in mind is that for our competitors, there were already drowsy driving detection on the internet, or available online. And one of the products was an earpiece that would detect when your head falls forward. But let's say if you fall asleep at the wheel and your head falls back, it's not going to detect that, and then you might cause an accident. So we wanted to make sure that our product could be used by virtually anyone, but it would mostly be directed towards truck drivers since they are driving late at night and for long hours. And we wanted to make sure that anyone could use this, no matter what ethnicity or what height, age were.
So here's some statistics that we found about drowsy driving. We found that 1 in 25 drivers admitted to be driving drowsy per month, and that half of all drivers overall have admitted to at some point in their life having driven while potentially too drowsy to drive. In 2013, there was 72,000 reported crashes that were reportedly caused by drowsy driving, and there was 44,000 reported injuries due to those crashes. And also in 2013, there were 800 deaths, and then that number increased to 5,000 deaths in 2015. So it was a huge increase over those 2 years.
So here is a very simple description of our system. At the top, you have the main part of our system, which is on the Raspberry Pi. It houses 2 pieces of software: the drowsiness detection software and the vehicle control override procedure. At the bottom, you can see a small diagram, which in our case would represent the vehicle. Now, the overall system is an integrated system. So we have the car and the roadside buddy system. The top, you can see that the inputs are the power and the camera, as well as, it's not on the diagram, but speakers that are used to alarm the driver when they are detected to be drowsy. In our case, we have Bluetooth communication modules, and each end of the system there are transmitters and receivers, so that both ends of the system can communicate with each other.
So this is the equation and formula we use to detect if someone was sleeping or not. So we did this depending on how close the eye is, and we use this ear to eye ratio, eye aspect ratio formula, which just takes these 6 points and subtracts them or add them together. So, for example, if the eye was closed, 0.2 would be next to 0.6, and 0.3 would be close to 0.5. So giving a ratio of 0 almost. That's in theory, but ideally, in practice, it's not going to be 0. It's going to be less than 0.2, 0.3. So this is the equation, and that's the code that we use to determine that ratio.
We can go back. I'd like to mention that this is just to calculate the points in the eye. Our software is based off a pre-trained model that was trained using machine learning to recognize objects in an image. Then using computer vision techniques, we filter out portions of that image to detect a face. Then once we do that, we filter out facial landmarks, the significant ones like the nose, the eyes, and the lips, but in our case we only care about the eyes. Once we do that, we establish the 6 points, and then once we establish the 6 points, we use this calculation to determine whether their eyes are open or closed.
So when we began this project, we started using the Raspberry Pi just because we've used it before and we already had one. But unfortunately for Raspberry Pi, they only give us this one schematic, and it's supposed to represent the whole thing. So if we were to create a PCB, we could never recreate it in a way to kind of mock the Raspberry Pi because we're not given all the components. So there's no way to actually make a full PCB. Now, when we figured out that we could not create a PCB just off Raspberry Pi, we looked into other options. And one other option that we found was the Beagle Bone Black. It is very similar to Raspberry Pi. It's just a little bit different. As you can see, this is just a comparison of the both. The major thing is that the Beagle Bone Black has more GPIO pins, so you can do more with it. And the price is like around the same and everything. So Beagle Bone Black has about 11 pages of schematics and the Allegro files, which is what you would use to create your own PCB. So if in the future we were to actually create a PCB, we would use the Beagle Bone Black as to help us.
So here's a housing unit that we 3D modeled and wound up 3D printing eventually. On the left-hand side, you can see there's a bowl cut out into the top, and that's where the speakers sit. And there's going to be a hole drilled into that bowl so that the speakers can plug directly into the Raspberry Pi that's housed underneath the bowl. In the front of the case, there's 3 holes. The middle one is for the lens of the camera, and the 2 on either side are for the infrared sensors on the camera. The infrared sensors are used so that your face can still be detected at night or in other low lighting conditions. When you flip the case on its front, that's the bottom view, and at the top of the bottom view, there's a space for the external battery that we're going to use. And there's also a slit cut out so that we can slide cover over the bottom to keep everything inside the case at once.
So here is a diagram of the functionality of both parts of our system. So I'd like to reiterate before what Ronnie was saying about our competitors. In terms of the earpiece, that all it does is that if your head tilts down, that will detect that you're sleeping while you're driving, so then it'll alarm you. And the other ones that are just expensive and are not integrated into the vehicle itself, so they lack any potential to take action in case someone does fall asleep at the wheel. With our system, since we are integrated into the vehicle, we can do one of 2 things. One, we can assess risk. So if the vehicle's not moving, then we won't trigger the alarm if the person is sleeping. So if you're at a stoplight, a stop sign or a stoplight, or if you're in park, if your eyes are closed, then it won't alarm you. It won't do any triggering of any speakers, and it won't try to stop the car. But if you are in motion at a significant speed, then we can assess your current speed and then determine whether you are drowsy in this case. At first, we will trigger an alarm and try to wake you up. If you don't wake up, then we take more action at a certain number of frames. If your eyes have been determined to be closed a certain number of frames, then we go into the override procedure and we try to slow down the car and come to a complete stop.
So this is how the eye detection software works. First, we have a camera that constantly is taking a feed in, and it resizes the image and it turns it into black and white because it's easier to perform it's easier to figure out those points, and it doesn't have to worry about 3 different color values. It just worries about black or white along that grayscale. And then once we do that, we do a facial detection. So just like Alex said, there's 3 faces, but we're only focusing on one face, which is the driver's face. All other faces are ignored. Once that face is detected, then the points are figured out. So where the chin is, where the nose is, where the eyes is. Again, like Alex said, we don't care about the others, just the eyes. And then we calculate the ratio. If it's less than a threshold that is predetermined, then we count that frame as a sleeping frame, and then we continue again the loop. Once that threshold, we have another threshold that says, let's say 10 frames. After 10 frames of being sleep or being categorized as sleeping frames, it goes into override and so on. So this is the test that we did. So first we needed to see if our software was able to detect the face and detect the eyes, which it did. And then also, after a certain amount of frames, is it able to produce a sound, which it did. And then lastly, is it able to, after let's say 10 frames or 20 frames, send a signal, a Bluetooth signal to the RC car to slow down? And it passed all those three tests. And then the communication between the Raspberry Pi and the Arduino was a Bluetooth signal. If it were to be implemented in a car, it would probably be serial. We just use Bluetooth in this case. And one of the tests was to see if there is a constant communication between the two, which it did by saying hi, hi back. And we need a two-way data because I need to be, or the software needs to be constantly asking the car, is it moving or are you not moving? If it's moving, then we're able to run the eye detection software. If it's not moving, there's no need to run it, save the CPU power.
And then testing the override procedure on the RC car side of the system. Our first step is to write an Arduino sketch to control the RC car. So we got Arduino operated RC car at first, and then we had to figure out how to control the motors and simulate a working car. The second step was to test the RC car in response to zero input, which is basically similar to the first part, just trying to figure out if we can simulate a working vehicle. And then three was to test and write an override procedure and see how the car reacts to signaling of a drowsy driver. And in our case, our software scales depending on your current speed, so to generate a safe stopping distance and decelerate at a good rate.
So this is going to be the demonstration video for the eye detection.
So here you can see that there are a couple frames or a couple of signals to the RC car, and they all say not moving. Then once it starts moving, it triggers to start detecting of the eyes. And then if you can see Arvid's eyes, there are two ellipses, the green one for the right eye and the yellow one for the left eye, and that is those are the points that we are using to calculate the eye aspect ratio. And the alarm's triggered.
So this is just the software without communicating to the Arduino.
Okay, so the next video is going to play automatically, so I'm just going to describe it before. It is the integration between the eye detection and the RC car together. As you see, the car is moving, and then the image is popping up of Arvid's face detecting. It sends a signal that he is sleeping, so the car slows down to an appropriate speed.
Yeah, so this should be working at nighttime. So we took a picture that, I don't know if you guys can see, but I still have the ellipses around my eyes, and we turn off the lights in the lab, and it's still able to detect our eyes. And then also, I took a picture from an angle. That's me actually looking straight and not at the camera. So it was able to detect my eyes from like a 60-degree angle from 90 degrees. So that's that.
So for future work, our main plan was to upgrade the camera because our camera only works for about a 2-foot distance away from the eyes. So if we were to get a better camera in the future, once it detects your face, it would be able to focus on your eyes so that you can keep it at a further distance away. Another one of the improvements that we wanted to do is we wanted to fine-tune the eye detection algorithm in order for it to run off of just one eye, because let's say you have the roadside buddy placed at a certain angle so that like your nose is blocking your other eye, that it would still be able to run the eye detection just based off of the one eye that is showing to the camera. And then obviously the final step would be to implement it in a real car, not just an RC car.
So this is just the bill of materials that we used for our project. We had the RC car, and then we had two the cameras. We originally had one, but then in like the final phases of testing, the camera just was not working. It would turn on, but then just shut off whenever we would run the program. So we just bought another camera thanks to Amazon for 2-day shipping. And then we had the Office Tech speakers, the Raspberry Pi, and then we bought a bonnet for the Raspberry Pi that would include the speakers. Just because our original speakers were too big and bulky, that we wanted to make sure that the housing unit could be as small as possible so that it wouldn't block the driver's view. And then we had the battery pack so that you wouldn't have to plug it into the car.
For the codes and standards that we had to follow, our main code was the New York State Article 9 code that had to determine whether or not the object that's placed on your dashboard would be in too much obstructing the view of the driver for the road. So you need to keep the device below a certain dimension to make the driver have a good visibility of the road. And then for the standards that we used the IEEE standard for Bluetooth connection between our Arduino and our Raspberry Pi.
And then just lastly, we wanted to make sure that the driver's identity wasn't going to be like stolen or anything, because we are filming your face, so it would be like safe. And we also wanted to make sure that this would work properly so that nobody would get into an accident or anything. And then you could use this if you were to get into an accident, like maybe why it happened and everything for insurance purposes. And we use open source software so that we wouldn't steal anyone's projects. And these are our licenses. Thank you. Any questions?
You mentioned kind of camera resolution. I'm sorry.
So, actually, I would like to say your work is very interesting. I have two questions. The first one, how do you overcome the faults and nerves? In other words, we know as a human we have different shapes and sizes for our eyes. So, how do you handle that? The second thing, these features detection was implemented a long time ago, and many people have done a lot of work. I want to know how different you work from the other people.
What do you mean by other people?
The people that work that we published, the other researchers.
I guess the main difference for our project is that the other competitors or projects out there, they haven't really tried to integrate into the actual system of the car. So yes, they can detect the drowsy eyes and alert the driver, but they can't really, like, all you can do is alert them. What if they don't wake up? We need to take over the car some way. We still, our goal is to save a life. So that's the main difference between our project and other people.
So that's why will come my second question. How do you overcome or handle the false attempts?
So we have a threshold that we put into place. So for example, let's say for one frame, I caught you blinking, and it would increase the flag by 1. But then the next frame, if your eyes are open, we'll reset the counter again, and then start all over like that. And then also one of them is like, if your face is not detected at all in the camera, we'll include that as a sleeping frame. Again, like our competitor, like this, you're not able to see the face, well, you're probably sleeping. But if you pick up your head again, the counter starts all over from 0. So that's how we did the false positive. And also, we increase the threshold to a certain point where after that, you have to be sleeping, or you're doing something else that is not driving.
You're looking at your phone.
Yeah.
Again, it's excellent work, and that's why I asked.
Thank you. Any other questions?
I have a question just about the camera resolution that you use, how much it costs. The resolution that the camera in order to be able to detect the eye and the face.
So in our future work, we want to get a better camera, because if you see, we had like a real fisheye camera. We want to see if we could just focus on that face, exclude everything else. So depending on the resolution and the distance of the camera would change how well we detect the eyes. So as future work, to get a better camera with higher resolution, because also the Raspberry Pi is not the best to do a computer vision, so it doesn't have the processing power. So I had to reduce the resolution actually of the camera so it could be higher FPS. So it was a Raspberry Pi. So
Stay with the camera. Does that have a IR filter in it, or is that something you can switch to the infrared filter on the camera? Is that being used?
it didn't have a filter, but it was placed. So as soon as I turned off the light, it just came automatically into play.
It might also be bugging all the time though, because
Yeah.
you do have like that purple hue.
Yeah.
Anything else?
Thank you.